The official Flipper Wi-Fi Dev Board costs around $70. This chip costs about a tenth of that, and it does the exact same job. Over the last 3 weeks, this Flipper cloned a keycard, stole a password with a fake Wi-Fi page, and typed a payload faster than any human could. The one thing it couldn't do on its own was Wi-Fi, and if you didn't buy the official add-on, you might assume that doors closed to you. It isn't. Today, I'm wiring a standalone ESP32 straight into the Flipper, running the same Marauder firmware the official board uses for a fraction of the price. Sub-GHz, Wi-Fi, and bad USB, all from one bench setup. No official add-on required. No new attacks today. You've already seen them. This is about getting the last capability without the price tag. Own hardware, own network, full transparency. Let's wire it up. Welcome back to the Tinkerer's Lab. If you've been here for the last 3 weeks, this one's the payoff. Everything we covered separately, wired into one combined build. If you're just landing here, you don't strictly need the earlier videos to follow along, but the Wi-Fi one especially gives context. Links up top. Quick note as always, everything I test at the end runs against my own hardware and my own network. Let's get into the parts. Let's start with the actual reason to do this. The official Flipper Wi-Fi Dev Board runs around $70 and it clips onto the GPIO pins on the back. A plain standalone ESP32 dev board costs somewhere between $5 and $10 and runs the exact same Marauder firmware. That's not a typo, and it's not a lesser alternative. It's the same chip family, the same firmware, doing the same job. The official board pays for the convenience of the clip-on form factor. If you're fine wiring 3 jumper wires yourself, you don't need to spend the other $60. Today, I will be using the ESP32 extension board as well for my ease of use, but it is strictly optional. There's a second reason too. The clip-on board sticks straight out the back of the Flipper. It's exposed, and it ties up the GPIO header for anything else you might want to attach there. A standalone ESP32 on a breadboard sits wherever you put it and doesn't commit those pins to one single accessory. Here's the key idea that makes the whole thing work. The Flipper already does Sub-GHz, RFID, NFC, infrared, and bad USB entirely on its own internal hardware. None of that touches the GPIO pins. Wi-Fi is the only thing it can't do alone. So the ESP32 handles Wi-Fi, talks to the Flipper over 2 wires, and everything else the Flipper just does natively. 2 boards, 4 wires, $10. Every capability from the last 3 weeks running at the same time. That's the whole idea. Let's build it on a breadboard so the wiring stays visible and easy to check. Here's everything you need, and it's a short list, and a cheap one. The Flipper Zero itself, obviously. A standalone ESP32. Mine cost about $8, and I'm using a plain dev board, but anything Marauder supports works. A small breadboard, 3 male-to-male jumper wires, since we're going from the Flipper's pin headers into the breadboard, and a USB cable to power the ESP32. One optional upgrade: if your ESP32 has a little U.FL antenna connector, a proper external Wi-Fi antenna genuinely extends your range compared to the stock dev board's tiny PCB antenna. This is a nice to have, not a requirement. And that's it. No case, no enclosure, nothing to 3D print. This is a bench setup you can wire up, test, and pull apart again in 5 minutes. If you want to make it more permanent later, that's a separate project. Today's about proving the wiring and the concept work. This is the part that actually matters, and it's only 3 wires. But get them right. The Flipper talks to the ESP32 over a serial connection, exactly the way it talked to the dev board. Serial just means 2 data lines crossed over. The Flipper's transmit goes to the ESP32's receive, and the Flipper's receive comes from the ESP32's transmit. So Flipper pin 13, which is transmit, goes to the ESP32's receive pin. Flipper pin 14, receive, goes to the ESP32's transmit pin. Because ESP32 boards label their pins differently, double check yours. You're looking for the pins marked TX and RX, and you cross them over, transmit to receive, both directions. Then the wire everyone forgets, ground. Take any of the Flipper's ground pins, that's pin 8, 11 or 18, and connect it to a ground pin on the ESP32. Without a shared ground, the two boards have no common reference for what a signal even is, and the connection just silently fails. If your setup isn't talking later, this wire is the first thing to check. Now, power. You could feed the ESP32 from the Flipper's 3-volt pin, but a Wi-Fi chip mid-transmission pulls current in sharp spikes, and that can brown out the Flipper's rail. So I'm powering the ESP32 off its own USB cable, straight into a wall adapter. The Flipper only ever shares two things with it, the data lines and that critical ground. Cleaner and far more stable than trying to share one supply. If your ESP32 is brand new, it needs Marauder flashed onto it first, and that's the exact same process from the week 2 video. Same browser-based flasher, just pick the build that matches your specific board instead of the dev board variant. I won't rerun the whole thing here, go watch that section if you need it. With the 4 wires in, layout is mostly common sense. Keep the breadboard between the two boards so the wire runs stay short, and keep the Flipper's USB-C port and buttons clear. If the Flipper boots but the ESP app shows nothing, don't panic. 90% of the time, it's that ground wire we talked about earlier. Check it first before you assume the firmware's wrong. Here's the whole point of the build. 3 capabilities, 1 wired up setup, no reconfiguring between them. Quick run through each against my own gear. First, Sub-GHz, straight off the Flipper, no add-on needed. I pull up the fixed code signal I saved from my own garage remote back in week 1, hit send, and it fires. RF done, entirely on internal hardware. Second, Wi-Fi. I open the ESP app on the Flipper, and there it is, network scanning in, signal strengths updating, all of it coming from the standalone ESP32 over those 3 wires on the breadboard. Everything Marauder did in week 2 works identically here, just from a board I wired up myself instead of one that clips onto the back. And third, bad USB. I unplug the Flipper from the breadboard and plug it straight into my own laptop. Select the harmless notepad script from last week, and it types itself out in about 2 seconds. RF, Wi-Fi, and keystroke injection, all from the same 2 boards, wired together on one breadboard. That's the build, and it's worth being blunt about the same thing I've said every week. Understanding how these pieces connect is genuinely useful, and that's exactly why the line matters. Everything here ran against hardware I own and a network I control. Point any of it at someone else's gear without written permission, and you're not tinkering anymore. You're committing an offence in Australia and pretty much everywhere else. The reason to build this isn't about having something ready to grab, it's to understand physically how little stands between a curious person and these systems, so you can defend the ones you're responsible for. That wraps the wiring build, but not the Flipper arc. There's 2 more videos left in it before we move on. Next week we're going past Marauder entirely, flashing custom firmware onto this exact ESP32 so it can take a command from the Flipper and act on it, starting with something as simple as switching on an LED. The week after that we build a real custom Flipper app to send that command, instead of relying on the Flipper's built-in tools. So, that's the Flipper and ESP32 wired together. A Flipper for everything it does natively, and a standalone ESP32 on Marauder, and just 3 wires between them. Nothing here was a new attack. It was 4 weeks of understanding how these systems actually work, folded into one combined build. And the understanding was always the real point. The moment you can build the thing, you can also see exactly how to defend against it. If this series was useful, subscribe. Next week we're going past Marauder, and I'll see you then.